However, the idea of all these things were given to you in the previous chemistry lessons. Today, when we will begin, let us first begin with acids. Acids are those class of compounds. Acids are those class of compounds which, on dissolving in water, gives H plus ions in the water medium. Means if an acid remains in its aqueous state, then you will have H plus ions furnished in the aqueous states. Examples of acids are HCl, hydrochloric acid, H2SO4, sulfuric acid, HNO3, nitric acid, H2CO3, carbonic acid, H3PO4, phosphoric acid. So this is hydrochloric acid. I am not writing acid, okay. This is sulfuric acid. This is nitric acid. This is carbonic acid. This is phosphoric acid. Okay, so there is phosphoric, there is carbonic, there is hydrochloric, there is sulfuric, there is nitric acids. Okay. Now, remember one more thing. H2SO4 is sulfuric acid, but H2SO3 is another acid which is known as sulfurous acid. In the same way, HNO3 is nitric acid. However, HNO2 is nitrous acid. So these two formulas and names, please remember. This is important. Another thing, there are also other acids like CH3COOH. This is known as acetic acid. In your carbon compounds chapter, you must have learned that meth is also known as ethanoic acid. However, there is also HCOOH. This is also acid. This is known as formic acid or methanoic acid. Two names. Now, this acetic acid is generally found in vinegar. Vinegar is only acetic acid. Formic acid is found in ant sting, bee sting. Okay, acetic acid, formic acid is found. So these are some examples of acid. Now here we have understood some chemical formulas of acid, and we will see this definition, or we will try to understand this definition, that why did I say that acids dissolving in water gives rise to ions. Hold here. See, suppose you take HCl. If you dissolved in it in water, if it is in aqueous state, then it will be H plus plus Cl minus. Means its ion will be released. Suppose H2SO4 is there, then it will be 2H plus plus SO4 minus 2. Suppose it will be sulfurous acid H2SO3, then it will be 2H plus plus SO3 minus 2. Now understanding this is very easy. You don't have to learn it to break it down. You just have to know that if you separate the H plus, how many H plus are there? Suppose H3PO4 is there. How many H are there? 3 H are there. So 3 H plus will be released. So remaining is PO4. You know that PO4 is phosphate ion. So PO4 minus 3. there is an acid HBr. This is known as hydrobromic acid. So H plus plus Br minus. So in this way, suppose there is CH3COOH, then it will break down as CH3COO minus plus H plus. This is the H plus that releases the this is the hydrogen that is being released as H plus in the water. However, if there is H in the compound, don't think, if there is H in the compound, please don't think that it is an acid. Don't think like that, because C6H12O6, it is glucose, but glucose is not an acid. Why? Because it doesn't release the H ions, H plus ions, does not release H plus ions in aqueous solution. So you should keep in mind that releasing of H plus ion and not releasing of H plus ion to be the criteria for being the acids. Okay, so you have learned about various acids, you have seen how they break down, and you have understood that who are to be called acids, and seeing hydrogen only you will call it acid. That is also not fair. Suppose for example CH4 is there, this is methane gas, it is not an acid because H plus ion will not be released in its aqueous state. So you should understand that these are some of the acids that is there in your syllabus, and you should understand. Now as a matter of fact, you see, if I talk about bases, compounds which release OH minus ions in the aqueous solution compounds which release OH minus ions in the aqueous solution are called bases or alkalis. Now what happens is, suppose NaOH, CaOH whole 2, then MgOH whole 2, ZnOH whole 2, KOH, NH4OH, these are all bases. These are all bases. So why are you calling them bases? Because NaOH, when dissolved in water in its aqueous solution, will release Na plus ion and OH minus ion. Again, CaOH whole 2 is there, then it will release Ca plus 2 ion and 2 OH minus ion. Again, KOH is there, then it will release K plus ion and OH minus ion. Suppose what else? NH4OH is there, then it will release NH4 plus ions and OH minus ions. So OH minus ions released in aqueous medium qualifies them to become base. Now to understand this chapter properly, yes, we understand that there exists acid, we understand that there exists base, and we understand that these are acids and bases. Okay, how to recognize acid? I hope that you can recognize that these are bases and those are acids very easily, because this was taught to you earlier only. However, now third class of compound that is there in your chapter is salts. Now salts are, I asked you to remember that except oxides, suppose Na2O or ZnO, except metal oxides, if you find a metal, or except a metal oxide and a metal hydroxide, except a metal oxide and a metal hydroxide, because you have noticed very well, I hope, in the previous page, in the previous that metal hydroxides are all bases and metal oxides will be metal oxides, they will have basic character. So except them, if you find a metal with any non-metal, or if you find a metal with any non-metallic radical or negative radical, then always remember that those are salts. CaHCO3 whole 2. These are all salt. How does it breaks Na plus Cl minus 2Na plus SO4 minus 2 Ca plus 2 HCO3 minus 1. Okay, so this is the way they break down. Okay, there can be lots. How many examples should I give? Suppose for example KNO3 is there, so that means K plus NO3 minus. Okay, so this is a salt. Whenever you see a metal with a negative radical, you will remember that it is a salt. Now in aqueous solution, salts also break down. Salts break down into their constituent ions. Salt break down into their constituent ions. Suppose for example you have taken NaCl, and NaCl will break down as Na plus Cl minus. CaSO4 will break down as Ca plus 2 plus SO4 minus 2, which is calcium sulfate. Suppose CuCl2 is there, then it will break down as Cu plus 2 plus 2Cl minus. So they break down in their constituent ions in case of salts. That we have this understanding. This is easy because these things or similar kind of things have been taught earlier also. So these are salts. Now I hope that you have an elementary idea in your mind that who are acids, who are bases, and who are salts, which was also given to you previously, but I have given in this introductory part of this chapter also, and then we can move forward to understand acids, bases and salts.